Hi everybody, now we're here for this 6.4 review. Let's get to it. Alright, so our very first slide here, just a review of some notation and definitions. Right, so the first one here is n factorial. Right, so for any natural number n, so any natural number meaning any number like 0, 1, 2, 3, 4, 5, right, counting numbers. We have n factorial is, right, so n times n minus 1 times n minus 2, and we keep decreasing by 1, multiplying all the way until we get to 1. Right, so for example, 6 factorial is of course 6 times 5 times 4 times 3 times 2 times 1. Right. Okay, so that would be, alright, so 4 factorial is 24. 5 factorial would be 24 times 5, which is 120. Then multiply that by 6, so you get 720. Right, so that's what 6 factorial will be, and n factorial is just start with the number and then multiply going down 1 unit until we get to the number 1. And then we just use a convention that 0 factorial is equal to 1. Alright, so next definition here. So permutations of n distinct objects. So we say the number of permutations of n distinct objects taken r at a time is given by, so we use this notation here, p and then in parentheses n comma r, to mean exactly that, the number of permutations of n distinct objects taken r at a time. And so we take n factorial, which is defined above, divided by n minus r factorial. So I have included on Blackboard links to how to use your calculator to do this, because it's just so much easier to have your calculator do this than it is for you to actually compute this, right? So on your calculator, that would be just, right, so you'll take your number, right, so a number would go here, then you'd click the NPR option, right, so your n would go here, and then your r would go over here on the calculator. Okay, so, and then, alright, combinations are, alright, so combinations of n distinct objects, so taken r at a time, and instead of using p and r, we just use c and r, right? So you take n factorial over r factorial times n minus r factorial. And the difference between combinations and permutations is that for permutations, the order matters, but for combination, the order does not, which is why you have that extra factor here of r factorial, because you need to take care of the number of ways that we can rearrange those r objects, right? R at a time. And if the order doesn't matter, then we have to take care of that. So you always expect that p and r is always greater than or equal to c and r, because for c and r, you divide by that extra factor of our r factorial, which makes the whole fraction, right, smaller. So just keep that in mind. So if you do c and r versus p and r, you expect that p and r should be greater than or equal to c and r. And the order does not matter for combination. So whenever you ask yourself which one to use, you have to ask yourself, does the order matter? Right? Okay. So let's, and then for, of course, on the calculators, you'd be using the NCR option. Okay. So next slide, and now we go right into an example. So let's delete. All right. In how many ways can 5 people boarding a bus be seated if the bus has 8 vacant seats? All right, so whenever I think of questions like these, I have to ask myself, does the order matter? Well, it turns out that whenever people are to be seated, whenever people have to line up, whenever, let's say, awards have to be given first place, second place, third place, right? Obviously, in those cases, the order does matter. So the way I think about it is, all right, so we have 8 vacant seats on the bus. There are 5 of us trying to get there and fill up those seats. Well, that means that the first person will have 8 options, and then that person sits down. So the next person doesn't have 8 options, right? They have one less option because there's already one person sitting there. So if you look at it that way, in terms of 6.3, the multiplication principle, you can think of it as, right, so the tasks, right, well, those would be the 5 people, right? And then you have to think about the number of ways these tasks can be performed. In other words, in this case, is the number of options for seats that these 5 people have. The way I think about it is, well, I'll just call them P1 as in person 1 or passenger 1, P2, P3, P4, and P5, right? So these are the 5 people, and the idea is each one gets one of these. So think of the first, there's P1 times whatever number of ways of P2, P3 is gonna go here, P4's number is gonna go here, and then P5's is gonna go here, right? So we said that the first person, right, so P1, I'll label these P2, P3, P4, P5, oh, and I have an extra. We're supposed to only have 5 people. So that should be enough, right? And then equals. All right, so the first person gets 8 options, right, for seats. All right, and then once that person sits down, the next person gets 7 options. And then, all right, so 2 seats are taken, so there are only 6 left. All right, 3 seats are taken, so 5. And then finally, the first 4 people have already sat down. We had 8 seats to start with, so there are only 4 seats left. And when you multiply these numbers, you get 6720. Okay, so that's one way of thinking about this problem if you're using the multiplication principle. Okay, but if you're using the methods for this section, right, then these will be permutations because the order does matter, right? First person gets a seat affects how many seats how many possible seats the next person has, affects how many possible seats the other person has. So whenever something like this happens, where choosing one option affects the number of options for the next person or the next choice, the next task, that's how we know we're using permutation. So this would be a permutation example, right? So another way to do that is, well, you would say we have 8 seats as option, 8 vacant seats, and we're choosing, or we're taking 5. So 5 will be the R in that equation in that previous slides. So you'd say we have 8 options and we're taking them 5 at a time, right? How many ways can we do that? Well, one way to do this is just enter this into your calculator. So you'd say 8, then you'd have your NPR 5, and then your calculator is gonna spit out the same number, 6720, right? So you can do it the way we've done it here with the number of tasks and the number of ways to perform those tasks, like 6.3, or you can do it the way of this section, and both ways work, right? So now suppose you don't know how to use your calculator to do this, then you would use a formula. You would say, all right, so P85 according to formula, right? So this is our N here, this is our R. So you'd say, all right, according to that formula, I know I'm supposed to do 8 factorial, that's our N factorial, and then I'm supposed to divide it by 8 minus 5 factorial. All right, and then that will be, all right, so you'd say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And then over, right, 8 minus 5 factorial, well, that simplifies to 3 factorial. 3 factorial is 3 times 2 times 1, right? And then from this point on, you can cancel the 3 times 2 times 1, 3 times 2 times 1 there in the top and bottom, and then you see what's left is 8 times 7 times 6 times 5 times 4, which is exactly what we have down here when we use the way of 6.3, right? So in the end, we still get 6720. So this problem right here, you can do it 3 different ways, right? You can just plug the numbers into the calculator, done. You can use the formula if you remember it, n factorial over n minus r factorial, or you can use the multiplication principle. So either way, you get the same answer, 6720, right? So there are 6,720 ways that 5 people can take up 8 seats on a bus. All right, so keep that in mind. So this is an example using permutations because the order matters. And then, all right, let's look at another example. Let's erase all this. Okay, so this is number 23 in 6.4 Webassign. We're trying to figure out in how many ways can a subcommittee of 4 be chosen from a Senate committee of 5 Democrats and 4 Republicans if... Alright, so option 1, all members are eligible. Well, the idea is you have to first figure out, okay, does the order matter here, yes or no, right? If the order matters, permutations. If it does not, combinations. Well, we're told that we're just trying to choose 4 people out of the total group, right? So let's first figure out how many people total there are, right? So total, well, total number of senators, at least for the sake of this problem, is gonna be, you'll take your 5 Democrats, so I'll say 5 Dem, plus 4 Republican, 4, I'll put Rep, right? So we have a total of 9 senators to choose from. And we're trying to choose 4 of them to make up this subcommittee. Okay, we're saying that everybody is eligible, so that means all senators are eligible, and we just have to choose 5 of them. Sorry, we have to choose 4 of them. Oh, that will be this number over here. So you have to choose 4 out of the total 9. It doesn't really matter in which order we do it because we're not told that we have to, let's say, choose a president and then a vice president and so on, right? We're just choosing 4 people. So here, the order doesn't matter. And usually, if the order matters, like the question will let you know that the order should matter. It will be phrased in a way that will make it really obvious. But in the case when they say all members are eligible in no particular order, you don't have to choose one and then choose another in any kind of order, then we know we're using combinations, right? So that means in this case that you want to choose, so C for combinations, out of a possible 9, you have to choose 4, right? So in other words, we say 9, choose 4. So in your calculator, or really we can use this as notation too, you can say 9 NCR4. And once you do that, you get that this is equal to 126, right? Of course, another way to do it, again, if you don't want to use this calculator NCR option here, or you just want to use a formula, you should get the same thing. But the idea is you're supposed to do, right? So remember that this is supposed to be n factorial at the top. So that means you get 9 factorial over r factorial, remembering that this right here is n, this right here is r, right? So you want to do 9 factorial over r factorial, so that will be the 4 factorial, and then times n minus r, which is 9 minus 4 factorial. Okay. Oops. Let me delete some of that. It's not very clear. Try that again. All right, so 9 factorial over 4 factorial times 9 minus 4 factorial. That's equal to, all right, so we get 9 factorial, so 9 times 8 times 7, 6, that's 5, that's 4, 3, 2, 1. So all those numbers multiply together. At the bottom, we get 4 factorial, so 4 times 3 times 2 times 1. All right, so 9 minus 4 factorial, that's the same thing as 5 factorial. So that's 5 times 4 times 3 times 2 times 1. All right, so the idea is instead of multiplying all these numbers together, you find the cancellations. So I'm going to cancel this 5, 4, 3, 2, 1 up here with this 5, 4, 3, 2, 1 down here. And then the idea is if you were to simplify this, definitely check, but you should get 126 regardless, right? But of course, doing it this way, when you just plug numbers into the calculators, is much simpler. So I would say make sure you get comfortable with using the calculator to do this, especially for the exam. It will just make your life much, much easier. Okay. All right. And then finally, number 2. So either way, 126 if everybody is eligible. Now let's go to the next question. All right, the subcommittee must consist of 2 Republicans and 2 Democrats. Remember, we still need 4 people, but now we're saying that we are putting like restrictions on things, right? We say that we have to have 2 Republicans and we have to have 2 Democrats, right? So the difference between this question and number 1 is in number 1, you could have all 4 be Democrats or all 4 be Republican or 1 and 3, 3 and 1, 2 and 2. Now we're saying that nope, we have to have everybody, right? So we have to have 2 Republicans and 2 Democrats. So what you do here, the way I like to set it up is like this. So down here, I'm gonna put the number of ways you can choose 2 Republicans, and then here I'm gonna put the number of ways you can choose 2 Democrats. Okay, so let's talk about that. Alright, so Republicans, so we know we have how many of them? So if you look it up, it's 4 Republicans. So we're gonna have to choose out of 4 Republicans, 2 of them. Now Democrats, we have 5 of them. So we have to choose out of a total 5, we have to pick out 2. So why am I choosing combinations instead of permutations? Because again, the order doesn't matter. We just need to make sure we choose 2. We don't care which 2. There isn't a systematic way to do it. Let's just choose 2 here and 2 here, right? 2 Democrats, 2 Republicans. As long as we do that, we're good, right? So again, in your calculator, you would enter 4 NCR2 times 5 NCR2. And once you do that, multiply the 2 numbers together, 60. So there are 60 ways to choose 2 Republicans out of 4 and 2 Democrats out of 5. And you want to multiply the possibilities together. Alright, if these 2 examples made sense, that's really all you need to know for the quiz for at least the 6.4 part of it. That's all you need. Okay? Alright, so now that we finished covering these few questions, I'm gonna go ahead and give you the password. So this week's password for the quiz is just the word count. So you want to do uppercase C and then lowercase O U N T. Right, so the only uppercase letter is C, the lowercase letters are O U N T. Good luck.